Okay, so the next section of our gyroscope frame, there's a couple of more holes that we need to put in. We're looking at putting those ones right here in the corner where eventually our wire ring is going to go around. And we could have done that on the milling machine when we did these additional holes here. But in the idea of getting through more people at a time in a normal lab, we typically go ahead and run these on the drill press. This also gives you a little more exposure to some new tooling. And then we'll use a sander to actually take those corners down at 45 degrees. But what we need to do before we do that is to mark out where these holes are going to be. So according to our drawing, we've got about 1/8 of an inch off of either side. It's going to be the location of those holes for the corner. And then the corners themselves are cut off at about 1/4 of an inch from either side. So we're going to go ahead and use some layout tools to identify where those corners are. And we'll use a punch, something similar to this, to actually start those holes, and then we'll take it over to the drill press and then the sander, and we'll finish that up. So this is, we're currently on what's called an inspection table. This is a perfectly flat granite slab, and this allows us to take height measurements off of this base, and also using certain tools to make sure that things are square and normal to each other. So we'll turn this guy on, and the first thing we have to do is make sure that we're zeroed out. So we always make sure that the bottom of our tool is clean, the surface of our inspection plate here is clean. We'll run this guy down here. We're a little bit off of 0. You guys can see that on there. So we're going to go ahead and zero that out. And we need to set the holes in the corners here at 1/8 of an inch on either side. So I'm going to go run and put some Dykem on those real quick, make it easier to see some scribe lines, and then we'll go ahead and punch those out. So I went ahead and marked 3 of the corners with red Dykem, and I kept our origin with the blue, so that if we bring our drawing over here, you can see the series of 3 holes and 3 holes lines up there. So we'll know that we'll go ahead and put that 3/16. So actually, that's another thing to mention there is, it does call out for a 5/32 here. That is if we're putting a 5/32 wire in there. We don't actually have any 5/32 wire, so we're adjusting this a little bit to a 3/16 hole because we do have 3/16 wire. So there's one small change that we're going to make to the plan that's not on the drawing there. Okay, so we'll go ahead and put that 3/16 hole, 3/16 hole here. We'll shape off both of these ends. And then lastly, we'll come back to the milling machine and put these holes in from the ends that'll support our spindle in the middle. Okay, so to use our vertical height gauge, we're going to go ahead, as I said, zero this guy out. We're flat on the surface there, reading 0 on there. And we're going to want to bring this guy up to 0.125. So we're close to that. Now I can actually lock off this upper one here and use this sort of fine adjust knob to bring ourselves down to wrong direction. Down to 1.250, right on there. Okay, then we can lock that off so it doesn't move on us. Okay, now that we've set our height gauge at 1/8 of an inch, and we've marked off our 3 corners in red and our origin still in blue, we mentioned that we want to make sure that we put our holes here on this corner and this corner for that 3/16 hole. So we're going to use our height gauge, and we're going to just place this along the edge there and just sort of scribe right along there, keeping that part as flat to the table as we can. Hopefully you can see that scribe line right on there. And we're going to do the same thing on this side, just like that. And right at the corner of that, we know that would be the center of 1/8 of an inch. So we'll do the same thing on this corner. Mark that one, turn it over, make that as flat as we can to the inspection table. And there's your other corner. Now we're going to move this up to 1/4 of an inch. So we're going to release both of these locks. Slide this up somewhere near there. That's pretty close. And we'll adjust down from there. Go right to 250. I think that's close enough. And so what we're going to do now is mark out the flats for the sides here. So same technique. Put the part on there. Just Scribe line right across that edge. You can see that on there. We'll be able to see that when we sand it. A couple more corners to do. There's one. All right. Make sure we can see all those okay. All right. That. And then what we have left is our origin corner. So make sure that's flat on the table. I'm just going to scrape that guy by there. And one more time. All right. So each of those corners is marked off 1/4 inch from the edge. So we know where we can sand. We'll look for those lines as we run the sander. Okay, now that we've moved away from the inspection plate, we want to go ahead and put some little dimples or some little start holes on these corners so that our drill bit doesn't wander as we start to drill that in there. There's 2 different ways we can do that. There's a handy little device like this, which is kind of a spring-loaded punch. We put this right on there. We put the point right at the intersection of those 2 lines that we drew. And we press down, and we get an automatic snap there. I don't know if you can see that or not, but we put a small little divot right in there, and that'll be a start point for our drill bit. If you don't have a spring-loaded device like that, a regular punch, same idea again. We're going to line that right up on top, and we're going to bring a hammer over and just go tap. Same idea. We get a nice little divot that helps our drill bit start on either side there. All right, so now we'll head over to the drill press. We don't do these kinds of operations on the inspection plate because it's extremely flat and we wouldn't want to chip it or put any divots or marks. So we want to use a nice solid back of a vise like that to do that. Okay, we're going to head over to the drill press now. We've got our part. Okay, we're over at the drill press and we're going to set our part into a drill press vise. This is sort of a cam lock device here. Set our corner out that we're interested in. Set it out just far enough to make sure we'll clear the vise. And then I've kind of adjusted this guy, a little bit of wiggle now so that when I pull this cam down, we snug it down but we don't crush our part. Then we'll go ahead and put our drill bit in. And tighten. I'm going to tighten this guy good and snug. All right, and we're going to bring our part over. And this basically vise has a really long lever arm on it, so we can hold this by hand, and that'll be easily able to overcome any rotational torque that we get as we drill. Still want to drill it kind of gently. We're going to go ahead and use that little hole that we made with our punch. Line that right up on there, and we'll go ahead and start the drill. Nice and easy. Remember to do our peck drilling as we come in. Nice and gentle. This setup isn't as rigid as the milling machine, so we're going to need to be a little bit easier. All right, there we go. That's clear. Now we'll turn it around, and we'll go ahead and get that other hole on the other side there. Okay, we can go ahead and get those chips cleaned off of there. I'll loosen this up. About to clean up those burrs on the back side. All right. In fact, maybe we need to go clean those up right now. All right, and some magically cleaned up burrs there. All right, we're going to put that back in our device. Clamp that down like so. Drill bit, make sure we're right on the corner there. Looks good. All right. Next hole. are nice. There we go. Those are a couple of 3/16 holes. So again, not as precise as a milling machine, but certainly more capable and more precise than trying to do it by hand. All right, next thing we'll do is we will cut these corners back to the lines that we marked on there using the sander. Okay, so we're over at the sander now, and I mentioned we're going to take off the corners of our part there to the lines that we scribed on there. So we'll flip the sander on, and if you thought the drill press was imprecise, this is much worse. We're just going to kind of go by eye here, work it back and forth across the belt. And all friction, so this generates quite a bit of heat. And also, I think we need to adjust our table, so we're going to go do that really quickly. Straighten out that corner a little bit now. Move it across. And go right to that line. A little burr in there. Pretty good. Same thing on this side. We're going to this line on either side. Almost. A little bit more. Touch off both sides. Make sure everything's even. Yeah, a little bit more. Want to make sure we can get that ring in there, so go slightly more than halfway is probably a good idea. All right, a couple more corners to do. A little bit more. Whew, that's getting hot. All right, in fact, I think we're gonna have to stop for a second to let that part cool down a little bit. All right. Okay, cooled down enough I can touch it now. Let's go ahead and finish up that last corner. All right, I think that looks pretty good. We'll turn that off there. Whew, got nice and hot again. I think if this were entirely up to me, I would not do it this way. Like I said, part of this is an exercise to introduce you guys to the drill press and the belt sander. One of the issues, I'm not sure if you guys can see that on one or the other of these. Here, let's disconnect this one. And take you over here to see this. The residual aluminum that's left on the belt there is not ideal. It does clog up the sanding belt. Usually cleaning it off with we'll actually have little rubberized belt sanding cleaner things, but you can also use this harder piece of steel or something will clean off some of that aluminum. So like I said, if this were entirely up to me, I think I would have done all those processes on the milling machine, cut off those corners, drill those holes. And if I were doing, 100 of these things or something, of course I would do as much as I could on the milling machine. Anyways, we've got those corners knocked off there. The last thing we need to do now is go ahead and drill the holes that come in from the ends of both of these sides here, top and bottom. We have a little mount on our mill that we'll go put that into and allow us to stand this part up vertically, this way, and then drill those holes in. So let's head back over to the milling machine and get those holes. We'll drill those and then we'll tap them, and we'll do that all in one step. So let's go take a look at that. Okay, we're heading over to the milling machine from the sander. And we're going to go ahead and put our gyro into the vise. Okay, so before we start just diving in and machining the corners of our part here, I want to take a second to talk about how this milling machine is set up a little bit differently than the last one. You can see that we actually have two vices set on here. As I mentioned when we were cutting the slots on this guy, you can set the vise up at a 45-degree angle, which is what we have on this one. But on this vise, we also have something what are called soft jaws. So I'm going to loosen our part up here and take this out for a second. Normally the jaws of the vise here are steel. They're hardened steel on both sides. I've taken this one out from here in the front. And those will hold your part. They're very accurate. They're machined, ground, and so forth, very precise. However, sometimes we need to make specialized fixtures that will hold our part, and we cut those out of aluminum or a softer material, and they're hence called soft jaws. If you look carefully at the jaw here, and hopefully I can move this, you can see that this was machined with a notch in there, a 45-degree, I should say 90-degree notch. It's set at a 45-degree angle. And this will allow us to slide our part right in there, hold it carefully on multiple sides, and also hold it in exactly the angle and position that we want for machining. There are multiple other examples. Here's a couple more soft jaws that have been cut. And these also will allow you to hold the part and machine past something. So as I mentioned, another way of doing this part would be to machine those corners. If we held it in a soft jaw, our milling bit could come through here, clean up those corners, and we wouldn't have to worry about hitting the hardened bits of this. We could literally just machine right through this because this is just as soft as the part that we're actually cutting. So I just want to introduce soft jaws, the concept of soft jaws, holding your parts. When we get to CNC machining, that's also very important because you're holding complex shapes, and oftentimes you have to machine the jaws in order to hold the part that you want. So we're going to take our part, we're going to line it up into that vise jaw, and we're going to close up the jaw like so. Try to reach around the backside here, make sure our part is set all the way down there and flat, flush, nice and square, and we'll snug that in there. All right, next we'll go ahead and get our edge finder, and we'll start finding out the edges on these guys. Okay, we're just also going to make sure that there aren't any burrs left on there because we don't want to pick up the edges of a burr. This is the actual edge of our part. So just cleaning that up, removing all sharp edges as it says in our plans. So now when our edge finder comes down, we don't pick up a burr, we pick up the actual edge. So we put our 3/8 collet up in there, and then we're going to put our edge finder in. Okay. And then we're going to reach it just snug. We need to raise our table a little bit here so our quill will be able to reach. That's good there. Let's turn this around so I don't smack my knee. Okay. And we're going to bring our quill down, make sure we get enough reach. Perfect. Let's lock that off. Okay, go forward. All right, so just like before, we're going to bring it back our table until our edge finder stops wiggling. And right there we kick off. We're going to zero our Y. Raise our spindle. Move well forward of our part. Bring the spindle back down, lock it off. And we're going to move our part back forward until again we get that wobble. And there we are. So now we can raise our spindle, turn off our machine, hit the brakes. All right, so now we know we need exactly half of 0.4554, which makes sense. We measured the thickness of this, which should be about 2.25, plus 0.1 on this side, plus 0.1 on that side. So 0.2 plus 0.25 gives us about 0.4554. So we need half of that.